Hello, everyone.
We can't hear you, Carlos. Check your mic, please.
Hello.
Okay, now it's working. Sorry, you can go. Thanks.
No problem. uh, I think I'm being muted. Hello.
We can hear you. I have to quote you. It just works.
Hello, everyone. We always have these challenges of doing things online. I hope everyone can hear me now. And let's start. First, let me say that I'm a big fan of Droidcon Italy, and it's truly a pleasure to be here. Although we're doing this live, it's truly a pleasure to be here and being part of this event. I want to also thank you for having me here and to be on the side of the screen. I know that we're living some difficult times, so I hope everyone's safe. But before we start, and I know that it's early in the morning, I'm going to try this. Let's just try to stretch out a bit. I want everyone to be fully awake, so let's try to put our hands up front. Now up. I'm assuming that everyone is doing this. And let's start. So welcome to this It Just Works, running Android running on Android desktop and web through KMP. And before we start, let me just say my name is Carlos Mota. I'm from Portugal. You can find me on Twitter at Mota. I'm the founder of GDG Coimbra. I'm also an Android GDE. I've been writing at Rio Wonderlic. I love to travel, photography, and running. And I truly hope that next year we'll all be able to taste Moretti with all of you. If this is not your favorite Italian beer, I'm also up to try new ones. So just hoping for being with everyone in person. For this talk, I've created these slides. They're available on my speaker deck. You just need to search It Just Works. I'm going to tweet everything at the end. I've created a template to easy the development for Kotlin Multiplatform and Compose. And I've created an application that I'm going to show you here. So all these links are going to be available at the end, don't worry. I also have a YouTube channel that I've been trying to publish video. So if I'm going to have my YouTuber moment, don't forget to subscribe my channel. And without further ado, let's talk a brief history of time. So we've been seeing throughout the past years a lot of frameworks that have been launched on mobile for mobile development, a lot of hybrid and cross-platform solutions like Ionic, Emotion, NativeScript, Kotlin Multiplatform, Flutter, and we've been seeing this not only on mobile but also on the desktop at a smaller case, and even on a bigger case on the web. These are the most common frameworks out there. There are a lot of jokes about this, like every 2 weeks there is a new framework. And to be honest, each one of these has its own advantages. And of course, it also has disadvantages. So let's start by talking about the myths of native, hybrid, and cross-platform solutions. Imagine that you've got a group with your tech friends, and you just want to say that you had a new app idea. So we're going to write, I've got a new app idea, and suddenly, and remember, these are your tech friends, is going to reply, great, are you going to do it natively? And then someone will hear this and say, natively. You can use Xamarin, and instead of Android only, you get Android and iOS for free. And then you've got someone from Flutter that's going to reply, for that, you should use Flutter, it has better performance. And then if I'm on that chat, I'm going to reply something like, but it used Dart, you're already familiar with Kotlin, you should try Kotlin Multiplatform. And then you're going to have someone from the web saying, I've been using React Native and it's great. And then you have got 12 more replies of people trying to advocate their own framework for you to implement. And you'll end up thinking, okay, perhaps I'm going to tell you just in the end when the app is ready and I can design the framework. So the first question here is how to develop an application. There are a lot of requirements that we need to think before starting development. And for instance, the biggest one might be the team background and its size. For instance, which language are your team familiar with? If your team comes from the web, perhaps doing an hybrid platform like React Native, it's a better approach. If you don't have a big team and you can't allocate a person for Android and iOS, perhaps doing native, it's going to be a bit difficult. So these are things that you need to think about. For instance, the project type. Are you going to develop just an MVP? Just want to ship something really, really fast? Or are you going to do a 5-year project? And when you talk about projects that have several years of development, you need to think about what's going to happen in 2 years' time, in 3 years' time. Does the framework still exist? Are you going to need to be developing for the framework and for your project? Are you going to need to rewrite the entire project? These are things that you need to think about. And of course, there are always constraints in time. If you're going to start a project, it's already late and you're going to try to speed up the development. Can you hire? Can you have a bigger team? Can you allocate more people to your project? These are always things that you need to think about. And of course, there are common disadvantages. For instance, if you select a cross-platform solution, you're going to have framework dependencies. For instance, and this happened to me a couple of years ago, I was using one of these frameworks and I developed an application for iOS. And then there was a huge redesign on iOS. And on iOS, typically after 2 days, 80% of the people updated to the newest version. So basically 80% of my users were still seeing my old UI because, well, I'm dependent on the framework itself. So I needed to wait 5 months for the framework to launch a new update. I needed to recompile my app. I needed to submit it to App Store. The users needed to install it. And in the end, I lost 60% of my users. And of course, the users that didn't update iOS were still seeing a new app that didn't correspond to OS layout. So it depends on the framework and not on the OS as it should be. Sometimes are missing features. If there's something that's only supporting on Android, typically it's not implemented because you're not going to develop only one. So you need to wait for the community to create their plugins. It has a slower performance. I know that this is always arguable, but you've got a layer in between, so it can't be the same performance. And once again, you're committing to one framework. The big question here is what will happen in 5 years' time? What will happen if someone stops developing the framework? Are you going to develop the framework and you're going to also develop your application? Are you going to rewrite all of this? These are some of the things that you need to think about before selecting one of these. Of course, I've got here a couple of spoilers. And for me, one of the best solutions out there, it's bit drum roll, Kotlin, namely Kotlin Multiplatform. First, you take advantage of Kotlin. So all the language features that you're already familiar with. And if you're coming from Android, this is really, really cool because you already know the language and everything that you can do. Also, it has low risk. You don't need to commit everything to Kotlin Multiplatform. Kotlin Multiplatform works with a business logic. And even here on this business logic, you can decide what you want to share. You might end up just sharing the network, the database. You're then getting better and better with multi-platform and you decide to share new things. And you can just move things to multi-platform and share it across all your platforms. Also, if something doesn't work quite right, you can just move that code back to Android. And of course, you need to implement it for iOS, but you already have one platform that's working fine. So it has really low risk. It also gives you consistency across platforms because you're going to share all of this across a lot of platforms. It also means that if you have an issue, you're going to have an issue on all platforms. But if you solve it, you're going to solve it on all. So that's a win-win situation. And you've got a really strong community support. The community is really incredible. If you have any question, just need to ask it on the Kotlin link Slack. And in a couple of hours, you've got your answer. So Kotlin Multiplatform, the goal here, once again, is to share your business logic. Let's see a simple example. You've got an Android application, an iOS, and web, a desktop, and you want to develop these 4 applications. So let's start with Android. You start by developing your view. You then implement your presentation, model, parser, network, and then you're going to do the exact same thing for all of the platforms. So basically on Android, you're going to use for network retrofit. On iOS, you're going to use Alamo Fire, but basically the logic, the business logic, it's the same. You're only going to change the library that you're using. So the goal with multi-platform or with Kotlin Multiplatform is just to share everything you're going to develop using Ktor for network, SQLite for database, and you're going to develop everything, the same library, and you're going to share it with Android, iOS, web, desktop, tvOS, watchOS, everything you want. Of course, when you talk about multi-platform and sharing code with a lot of platforms, there are things that we need to think about. For instance, there are different implementations depending on the platform itself. Let's see a simple example. Imagine that you want to log something on the console. On Android, use the logger, the log. On Android, on iOS, use the NES print. I think on the desktop, you can use println. And you want to have these specific behaviors on each one of these platforms. So how can you do that? Let's see a simple example. Imagine that you want to show a message on Android saying hello Android, on iOS hello iOS, on desktop hello desktop, on the web hello web. So you've got here a variable property that's going to change depending on the platform that you're running. Now let's call this property name. If you want to have something that's going to be platform specific, you're going to use the keyword expect. So I expect someone is going to say what name it really is. And this is defined under common main. This common main, it's a folder that contains your shared code, namely the common code that needs to be defined. So if I'm going to develop for Android desktop and GS, I need to say what expect really means. So I'm going to navigate to Android main. And as you can see, I moved from common main to Android main. And I'm going to say that actually what name is Android. And then I'm going to go to the other targets and I'm going to say, okay, what name is on desktop? And I move to desktop main is desktop. What web main is, it's web. And with all of this, when I'm going to compile the project, I'm going to have on Android, desktop, and web. So basically, I'm going to define all the expect classes and all the common code, all the business logic to access my server, to start locally on this common model. And then I'm just going to generate R files, jar files, frameworks, GS files, upload it to NPM that I can use individually on each platforms. So how to develop an application? The answer is quite simple, Kotlin Multiplatform. And we can even improve this by also adding compose. So compose got really trending this year. We started perhaps on February implementing it on my company, and we are really happy with the results. We've been decreasing a lot the development times. Of course, that if you go to the official website, you're going to see that you're going to write less code, it's intuitive, it's going to make your development really fast, and it's really powerful. And all of this is true. We couldn't be happier with the results. But truth to be said, there is more to compose than it. And we've noticed this a couple of months ago when Wharton tweeted this. Basically, he was mentioning that he was using Compose for iOS on an internal project, where basically he was just using the compiler and the runtime, and he created the top layer in the other working example. And we immediately, with this, I and a lot of people noticed that we weren't seeing Compose as the true potential that it has. We're just seeing Compose as, okay, we can no longer develop with XML. We're going to use declarative UI, and we can do this on Android, but we can do it much more. For instance, if you go to the Android documentation once again, you're going to see that the Jetpack compose is composed by the compiler, runtime, UI, foundation, material, and animation. And if we have an high-level diagram with this, we can have the Compose UI toolkit, let's call it this way. That's composed with UI, foundation material, and animation. And then we're going to have the compiler and the runtime. If we look at the compiler itself, well, the compiler is fully written in Kotlin. It's available on the IOSP. You can always check the code. It's really interesting, let's say. And basically, it's a plugin that generates your code at the system level and doesn't increase build times because it's not going to use the annotation processor for this. Then on top of the compiler, we're going to have the runtime, which is platform agnostic. So he has no clue what Android or what the UI is, and is more of a tree management solution. There are a couple of projects that are using Compose in projects that don't have UI. And of course, there are projects like, I think it's also from Wharton Mosaic, that is for the terminal, for the console, that uses Compose on the background. Now that we have this compiler and runtime that have no clue what a UI is, this runtime, we're going to have the Compose UI toolkit that Android uses and that you use when you develop on Android. So you've got animation used for having those beautiful animations, the material that it's the system design that your application can use and can extend, the foundation that contains all the base composables like column, image, text, row, everything, and the UI that deals with input management, for instance, entering text on the keyboard, etc. And now that we have this, we can easily, and I'm going to say easily between quotes, but we can have the desktop Compose UI for the web, for the console, for the Raspberry Pi. Basically, they're going to use the Compose runtime and compiler, and then they have the new UI toolkit on top. Instead of having for Android, they're going to have for the desktop, for instance. And it's really cool because last month, JetBrains announced that Compose Multiplatform has reached beta stage, meaning that the API should be almost final, and you can start adding it to your projects. So Android, desktop, and web. I've mentioned that I've created a simple application for this. It's called basically Unsplash app. I've created an application that queries the Unsplash servers. It gets the most trending images. It shows the image, information about the image. It allows you to search for something specific. In this case, I'm going to search for my home country. This is Portugal. And then you can navigate between two screens. So it's a really simple application just to showcase the power of multi-platform and Compose. And then I had this application ready. I moved the code and have the web version ready. So this is Android Wear running Compose. And then I did the exact same thing and shared this code with the desktop. So this is the desktop version. You will see in a couple of seconds why this is a desktop, because I can resize at any moment. See, this is the desktop version. I can resize everything. And then, of course, we also have a web version. And it's worth to mention that this web version, it's the most difficult part here with Compose. So I bet the big question that everyone is asking is, now that we have the Android app ready, how quickly can we have desktop and web applications? So let's play a game. So select your level. I just want to see the story. I want a lighter experience. Give me the full challenge. So let's go with this full challenge. So we're going to have Kotlin Multiplatform to share the business logic and Compose to share the native UI. Let's start with multi-platform. So when you're targeting Kotlin Multiplatform, you can target for all of these platforms and a couple more. You can use it on the JVM, GS, watchOS, macOS, Android, iOS, Windows, Linux, you decide. And then you already have a couple of libraries that work and are really, really good for instance, like for coroutines, serialization at time. Network typically use Ktor. For storage, you use the database, the SQLite. And you've got a big list of these that are being created by the community and are available under Akira's Kotlin Multiplatform libraries GitHub. So you need to use a library that's full Kotlin. You cannot have Java code. And of course, this library was compiled with a specific version of Kotlin that needs to be compiled with your project. This is why you can't use, for instance, Retrofit, because it has Java code in it. So how to start? The easiest way to start a Kotlin Multiplatform project is basically to install the KMM plugin if you're running on a Mac, and then create a new KMM application. You're going to have a template for this that you can easily use it. When you create your project, you're going to have 3 folders: Android app, iOS app, and shared. This shared, it's where you're going to have your shared code. The Android app contains all the Android application resource files, your activities, your XML, your Android manifest, your XML files, everything. The iOS, that in this case, we want to change to desktop and web. Basically, I'm just going to copy Android app and then rename it to desktop and to web. And then we're going to have the shared folder where you've got the Android, the common main, and now once again, the desktop and GS main. So on common main, as you saw before, there is the expect and all the logic. On Android, desktop, and GS main, you're going to have all the platform specific code. But there's more to it. On your Gradle configuration file, when you create this project, you have 2 targets, Android and iOS. But we want to target desktop and GS, so you're going to need to remove iOS and just add GVM and GS. So GS, I'm using the IR compiler, and my advice is that you should also use IR compiler. The end files are way smaller and you don't have as many problems as if you're using the legacy mode. And now it's time to migrate your APIs to use, for instance, Ktor. And for that, you need to add the source sets for Android, desktop, and GS, and use your Ktor client. And in this case, you need to define the client for Android and the client for GS. If you're also going to use iOS, you should also need to define the Ktor client for iOS. Talking about migrating to a new database, instead of using Home or Core Data, you're going to use SQLite. So you need to also add the drivers. And since you're going to use serialization for responses, you need only on the common main to use Kotlin X serialization. Of course, I'm saying this, and this is sounding really easy, but you need to migrate all the API calls. So it's not just replacing libraries. You need to migrate all the API calls that you're doing from retrofit to Ktor, from Alarmfire to Ktor. You need to migrate everything. So I bet the big question that you're doing here is, okay, you're saying that I need to change a lot of libraries and I need to migrate all the API calls. This is going to take you a lot of time. So do I need to refactor the entire project? No, you don't. Once again, multi-platform says that you need to decide what you want to share. You may end up just sharing a small part, or you can share everything. And this slide is from a Kotlin Conf a couple of years ago, and they give an example of different applications that are already in production and sharing different parts of their code. For instance, Space is full Kotlin multi-platform, Cash App shares the business logic, IndexMap shares the business logic and wrappers for C++ libraries, Plain Grid shares also the sync logic and management of line data. So they share what they think it makes sense for them. So my best advice here is that you should start small. You're going to develop a new feature. Perhaps we can do it on multi-platform, or you need to refactor some part of the app, or you want to improve text coverage. These are all good scenarios where you can start doing with multi-platform. If your team likes the result, if your management is happy with the result, so it's time to, on the next sprint, add a few tasks to migrate more code to multi-platform. And you're doing this in increments, and you're going to face, of course, challenges that you're going to solve. And you're going to be motivated because things are working, and you don't just refactor the whole thing in a short time and you're going to see a lot of issues. No, you're going to do things in increments, and you're going to see that everything is going to be perfect. Of course, you're going to find a lot of challenge in the way. For instance, one of the biggest one is that not all libraries are available on Kotlin multi-platform, and those that they are available, they might not support all the targets that you want. I'm going to show you further down on this talk that I was using a library that didn't have a support for desktop, and in this case, it was quite easy to add this support for desktop, but on most libraries, it's not. It's also important to mention that you need to use a library that is compatible with your Kotlin version. So when you're going to search for a library, check if it has recent updates. The initial project configuration may end up taking some time. You're going to do some invalidate caches and restart if every time you need to add a new target. And there are properties that I was hoping that to be more specific on the documentation that there aren't, but well, I can enumerate if you like. For instance, you need to export to have access direct to this code from iOS. If you're targeting for the web, you should also use the GS name. And otherwise, your methods, your functions, it's going to have a really strange name. And these are the small tweaks that you learn along the way. I'm going to write a blog post in the nearby future about this. And of course, you can always come back to this slide or looking at the samples that I've created. I think that it's a really good configuration file. At least I've been using that since the beginning of this year, and everything is being working really, really good with us. When you're targeting the web, you also need to enable the IR compiler. And if you're targeting the web, there are a couple of things that you need to think before. First, the end file, the generated GS file, it's going to be really big, and you're going to need to use compress and minimize, zip and minimize. And there are, if you're using, for instance, enums, they're not ported at this moment for IR. Tree shaking is also not working 100%, so you need to use, for instance, the Google Closure compile plugin for that to minimize. There are still, I put it in red because it still has a lot of challenges along the way. Now that we're talking about multi-platform, it's time to go and dive into Compose, and we're going to share Compose with everything. So how to start? If you're going to develop Compose for the first time, my advice is that you should start with developing your Android application and then migrate your code to the desktop, for instance. If you're already familiar with Compose, you can just try it and go on and try to conquer all platforms without any bigger issues. So first, you need to create a shared UI model and then add all your code to that shared UI, and you can just copy paste it. Of course, if you want to share your Compose code across Android and desktop, for instance, or also the web, you need to do a bit of Kotlin Multiplatform. So different platforms mean different behaviors. For instance, Android has a specific way to access resources. You're going to use it via r.drawable or .string or something like that. On desktop, you're going to access an image with the full path of that image. There is no concept of an R file. So you're going to use multi-platform to use expect actual to handle this. And of course, there are different APIs that you can use. For instance, Android typically don't resize windows, although you have the split screen. On the desktop, you can resize the window, and you have the window API for this. So Compose for Android, use Android X Compose. Compose for desktop and the web, use JetBrains Compose. It's currently on the beta 5, and you can add it to your project with JetBrains Compose and then the version. And instead of using the full path like Android does with Android X, compose, material, etc., you can just call compose.foundation, runtime, material X, icons extend, etc. And now if you're going to compile the project, you're going to have you're going to have a duplicated classes. Why? And your build will fail. Why? Because you're using two different versions of Compose. So you're going to use the Android X Compose, the JetBrains Compose, and in the end, the compiler doesn't know which version it should use. So the right thing is, instead of using the Android version on the Android app, you're going to use the JetBrains Compose. And basically what this plugin is going to do on the background, it's going to replace one library with the other, and everything will be smooth and working. Once again, the big question here is, do I need to refactor the entire project? No, you don't. Compose is interoperable with XML. You can also decide what you want to share. It's only on this case, you need to share the entire screen. And you don't need to rewrite your entire application with Compose. You can just share the features, the screens that you want with Compose. So which challenges are you going to find along the way? Well, once again, and I think once again, this is one of the worst parts, is the initial setup. It's quite challenging because you need to use the JetBrains plugins, and there is not real information about this. And then you're going to have, you need to be really careful with the configuration steps. Sometimes you add the wrong configuration and you increment a lot of the building times. libraries depend on the Compose version. For instance, on Android, you now can use 1.5.31 with Kotlin and the 1.05 with Compose, but the 2 versions ago, it wasn't possible to use the 1.5.31, so you need to wait for the release of that version. And if you're using a library, the library needs to be compiled with this new version. And of course, not all the features are available for desktop and for the web, unfortunately. The fact that we have a library that's available for Android, it doesn't mean that that Compose library is also available for desktop or the web. Also, there is no direct support for internationalization, for fonts and other resources. You need to implement that by yourself if you want to share the code. Also, if you're coming from Android and if you use live data, view models, etc., they are only available through third-party libraries. And of course, web, although it's Compose, it's reached beta stage, I've faced a couple of issues. So, in my opinion, it's still on its initial stage. They're way more focused on writing the DOM elements and manipulating them. How to solve these issues? For instance, one of the best libraries that I think that we have on Compose, it's the Accompanist library. It basically gives you a lot of features for free, like the insets, system UI, controller, pager, swap to refresh, permissions, everything is given for free. And then if you start navigating throughout the GitHub, you're going to see that there is an issue saying that converted to Kotlin Multiplatform, and then you're going to see that not all Compose libraries are available for desktop and the web, and this is one of them. Fortunately, community for the rescue, someone ported it to desktop and web, and you can use it. This is the Accompanist by CR10. Not all of these libraries are already ported, but fortunately, the most common ones are. For instance, you already have the page, the swap to refresh, everything. Unfortunately, it only works for the desktop. I know. But this is quite easy to solve. Basically, you just need to download the project, add it to your project, and you'll see here that you're just going to use the GVM. So you're not really targeting for Android. So what you can do, it's quite easily. Basically, you add the Android library plugin. Since you're adding this plugin, you also need to add here the Kotlin Android that's going to publish the libraries. Since you're going to do this, you also need the desktop version, and then you just need to define the source set, and you're up. Basically, you just, and of course, you also need to define which version of with Android that's going to be compiled, the target version, the min SDK, where the XML file, Android manifest file is, and with this, you've got support for Android and desktop for free. Another thing, it's the image loading. For instance, I was using Coil, basically because it was one of the first libraries that was available for Compose, and I was trying to use it on the desktop, and basically you can't. And according to Colin, not sure if it will ever be possible. Once again, community for the rescue, there is a cool library called Kamel. Basically, it allows you to load images and works on Android and desktop and uses Qt in the background. It's fairly similar to Coil. Basically, this is a Coil request. You're going to have your remember image painter. You can have the current state by accessing the image painter.loading, success, failure, etc. And you use image to add an image. So if you want to do this with Kamel, it's fairly simple. It's the same thing, but instead of using an image, you're going to use a Kamel image, and it will handle everything for you. Moving forward, imagine that instead of accessing a remote image and downloading a remote image, you want to use a local one. For instance, you just want to show here an Android. Typically, you do something similar to this. So we've got your painter resource and you have a local image from r.trouble, but r.trouble, the R file is something Android specific that you don't have on the desktop, on the web. The same thing for strings. So we need to create an implementation for the desktop and for the web. And the easiest way to do this is to use Kotlin Multiplatform with expect and actual. So you want to have the icons for the button bar, for the navigation bar. You can just say something like, I expect someone that's going to define what I see about and I see home is. I'm going to say that they are painter. And then on Android, I'm going to define the actual implementation of IC about, that it's going to access the R-Trouble IC about. And then on desktop, of course, you're going to use the full path to access the painter resource. Now imagine that you want a custom font. Fonts also use the r.font to access the font element. So you, for instance, you would use the typography for this, and then you access the file with r.font and then SF volutes healed, because I thought this is a cool font. So you need to do a font implementation if you want to access this for the desktop and for the web. So basically, you can create, once again, your composable function with expect, and you are going to expect a name and a resource. And then on Android, you're going to use the context to get identified font and with a package name. And then if you're going to the desktop, you're going to do the same thing, but instead of using the resources, you're going to access directly the text platform font and give the full path. If you want to use live data, for instance, there is a really cool and good library called PreCompose by Tlaster. And it allows you to use live data without any bigger problems directly on a desktop application. So we've been talking about desktop. Of course, there is also the web. Unfortunately, the web, as I mentioned before, it's still on its initial stages. The paradigm is a bit different. For instance, typically on Android and desktop, you can use a column and you can use the modifier for max size, max width, and then you've got everything on top of that. The web is focused on DOM rendering, and there is only just a small set of components that are available. For instance, it's box, button, column, row, slider, text. You don't have all of them. And typically you still need to use, as you do on the web, to use, for instance, divs, and then you need to apply a style, and on the style you define the width and the height. And of course, you can create components for this or composables for this. For instance, you do something like this, but the over-engineering of doing such solution, I think it doesn't, it's not worth it for now on doing everything with this, because you need to create an expect for Android desktop and the web, and then, an expect for column, and then on the Android, you're going to use column, on desktop, you're going to use column, and then on the web, you're going to have this actual implementation. And you're going to need to do this for almost every composable, and you may end up needing a lot of time to do this. So talking about the web, sharing logic works without any issues. The generated GS files might end up having several megabytes, and you need to use additional tools to try to reduce that. Sharing the UI is going to be time consuming. You're going to need to create several components, as I was mentioned, and most of the libraries that are available, for instance, the Accompanist library, even ported to the desktop, there is no direct support for the GS. Nevertheless, being said, we reached beta version with Compose, so I'm sure on the next months we're going to see a lot of cool things for the web also. Getting everything together. So the Kotlin Multiplatform is more than stable. I think it's going to reach beta somewhere in the beginning of next year. Compose of Android is more than stable. For desktop, it's alpha-ish, beta-ish. For web, in my opinion, it's still on alpha. The documentation and samples I could use a bit more, but you've got a really communities and support for the Kotlin and Slack. So any question that you have got an answer in a couple of hours. Here are a couple of resources that you can use to learn more about the platform and about Compose. I'm going to tweet the slides at the end, so don't worry to copy this. And I thought it was interesting to add one more thing about this Apple concept, although we're not targeting iOS here. So we were using as a level, give me the full challenge. We can go a bit back and let's ask for a lighter experience. And one of the things that I've mentioned was that the setup of the project, it's really difficult if you want to create your project sharing the multi-platform code, the business logic, and the compose code. And it may take you a while to do all of these and finding the right configuration. So in the goal to help you out, I've created a simple project. I called it Alicerce. This means foundation in Portuguese. And basically it allows you to create an Android and desktop application where all of the code is shared. And basically you're just going to use a library for this called cookie cutter. Basically you just write cookie cutter and then automatically it's going to ask you a few questions. And after filling everything, it's going to generate a project with everything already configured. So feel free to use it. Of course, I'm open to feedback and contributions. And if there is a feature that you think that I should add, just drop me a message or create an issue on GitHub. So I'm going to now open for questions.